So please, my presentation. So my presentation is much more focused on the integration of different technology today available, from satellite, helicopter, drone, ground, and so on. One of the most important aspects of all of this technology is that all of them are non-invasive, and this is very important when we are dealing with cultural heritage. So this is just a focus on the outline of some case study, and let's go quite fast. Today we are in the era of big data. It's not easy to say what is the meaning because it depends on the discipline, but what is for sure is that we have a lot of data, but actually they are not exploited as should be. From, let me say, different application, one of the most important aspects is to move from data to information, to knowledge. This is the most important need. And of course, the integration of different data sensor can complementary provide information. And again, this is another important need, that is the integration of different background. And so we need to move from single discipline to multidisciplinary and interdisciplinary approach, as, for example, is in the Copernicus approach, by the way. In fact, Copernicus is based on 4 pillars: the spatial component, the in situ measurements, the harmonization of all of this data, and then we will move from science, from research, to service for user, as Artec project do. Actually, there is also an interesting debate inside the European community, and we have the pleasure to take part of this important workshop, where was discussed about the possibility to focalize some Copernicus services for cultural heritage. Next talk will be in India. We will invite it in December. So just now some example, because we can have, it's not clear, but we discuss about crop marks. It's quite traditional, well-known, well-defined, because is the traces, the proxy indicator that we can have from vegetation. So according to this long literature, we expect to have these marks, the visibility, much more during spring, but actually it's not, because we can have, is not in the laboratory, our vegetation. We have real vegetation in real world. This means that we have the impact in the vegetation growth of a meteorological condition, of course, the crops, the soil, and also the technology used for the cultivation. Can have, this is from one year to another, the visibility according also to crop, but of course what is evident from this picture is that yes, you can have, it's not clear, it's much more clear in the next slide, you can have some evidence in spring, but we have also some evidence in August where there is no crops but spontaneous vegetation cover. So it's not easy, it's not from the feasibility point of view, economical point of view, we cannot have this acquisition using satellite. We can have, but it's expensive, of course. So the idea is to improve the modeling and to have the possibility to determine the best period of the year. And this can be done using a drone. This was a very nice application that we made in cooperation with the Italian Space Agency, and actually the drone survey was made by Mino De Marzo that year there. And this was a very nice cooperation, and actually we had the possibility to investigate. We had, Mino had the acquisition with this group, of course, from 1 month to another, so at the end we were, for this site, able to recognize or the mark, but the most important interest from the scientific point of view is the modeling. Another important modeling is linked to what we do in the last years, for example, for monitoring illegal excavation. We made this application using satellite data and also Google Earth, because again, the point is to have the best at the lowest price. So we made the real data, multispectral, but also using only, again, Google Earth data. We were able, applying to our methodology, to have all of these extraction using unsupervised classification. Of course, it's not possible to check there, but we apply in Peru, in Cahuachi, the same approach. And of course, in Cahuachi, we extract in automatic way this map, and we were able to go there to check, but our interest is not only to have the, let me say, ground verification. There is, in our opinion, a very important point. When you have illegal excavation, you lost forever the cultural context, not only the artifact that maybe could be recovered again, but we cannot anymore recover this area. So our attention is to provide these sites a second chance so we can go there with geophysical prospection to check the structure. And I would like now to go on from satellite to the integration, moving from Peru to Matera. This is a very nice, interesting study made in cooperation with DigiMat in a joint project. And in this case, we have indoor and outdoor. So indoor microclimate monitoring is made using traditional low cost. This is the new impact. And of course, outdoor is made using the integration of meteorological information, but also satellite data. And I would like to show you what I mean when I say integration. You can see here, this is Landsat, more or less the same, oh, sorry, the same showed before. I have a problem with this, but in any case, we can go fast. When I speak about the integration, we speak about the integration of all the available data. And in this case, if you go here in the Copernicus information for air quality, you have a very nice and interesting forecasting of different pollution. So the idea is, because the pollution impact cultural heritage, to have this information from Copernicus, and in the next time using Sentinel-5 at 7 kilometers, the highest spatial resolution for this type of investigation. But we can have detailed information using, for example, TM. We developed a model, and this is the computation of PM10 using satellite data. So going back to the crypta, we have the possibility to have this monitoring inside and outside to define some thresholds. And of course, the most important point, again, is to, I don't know why, what is the reason, but we can, okay, to also have the possibility to model inside and outside in order to have this information, even we have no possibility to have inside network of measurements. So this is very important. This is very interesting. Think about how many churches we have, where it is not possible to have this detailed information, but the idea is, again, to model, to reapply using low-cost technology again. So on the basis of these, this was the main basic idea of, ArtTech project, because according to UNESCO, we have different critical issue. You know, when you have an UNESCO site, the inscription is not forever. You have to maintain exactly the same situation where it was put in UNESCO. If not, there is in danger, and if not, it can be totally removed. As, for example, in Dresden, we have a Vienna endangered list, so it's not only for some specific country, even in Europe we have this. So we can deal with the different, and in this case, the integration is mandatory, because it's not possible to have risk estimation if you have not good integration of different parameters useful. But according to UNESCO, this is, of course, natural or anthropogenic risk, but also the management. And this is the main focus of ArtTech, that is funded by European Space Agency with the cooperation of Italian Space Agency. And the main focus is, of course, not the preventive, let me say, that is the core in the middle. What is important is the improving preventive. Not when you have the damage, but you have to manage the site, UNESCO and also non-UNESCO site, using this very important information. That's why there is a very interesting integration of different institutions. There is NICE, that is the prime. We have Corini here, that is the chair of NICE. And of course, we have different National Council of Research, we have ISPRA, we have MIBAC, because again, the integration of different expertise is really one of the most important points. Then then there is the society, then there is, of course, the selection, in the case of Artec, the different case study with the different, of course, issue, Matera or Baia, where we have, for example, land, but also underwater archaeology. Just it's enough. So the idea is to use satellite, the integrated approach, in order to provide not only the monitoring from satellite, drone, and so on, but also the possibility to support the management. Just to show you, this is Villa Adriana, and the site manager asked to NICE to monitor the state of roof. This is a very important issue because you can have some biological patina that is very dangerous for this type of structure, but also some crack. I would like just to go on again with the interferometric made by NICE again, because it's one of the most, let me say, is one of the technology that is most ready to be applied as in this case. This is for Villa Adriana, but what I would like to show you is for Civita di Bagnoregio, when we have active landslide. So Civita was proposed for the UNESCO nomination, but was not accepted because lack of monitoring. So NICE will provide the committee for the next nomination, providing these services that again is integrated. We have the interferometric, as you can see and discuss it, but also some ground station, because the interferometric can provide a slow movement, but unfortunately sometimes we have fast movement. And from this point of view, of course, the integration of, I finish, different sensor, technology, expertise is the key for the future. Thank you for your attention.